Alright, another help request for exercise 8.3. So let's take a look. So isothermal CSTR, series and parallel reactions. Let me maximize the code that I received. Oh, gotta bring my head down with me. Let's go through it and see what we have. So function with no input. So series 10th, I'm assuming that's just going to refer to this. We'll play with this later on, but again, you could always just make this multiple in input, and then that way you could just create a general function and use it for all of our cases. So you have our activation energy, which you convert to joules per mole. Cool. Okay, and that's the same for each. RT, pre-compute your rate constants. That's good, since our temperature is constant, it'll be the same throughout. Create a vector of tau values. Collection vectors for CA, CB, and CC. Loop over tau. Create an anonymous function so that the only input is cvals. And so then here's must be my general air function, which will pass K1, K2, and tau range. Okay, so my guess, right? So I guess I should, the email that was sent to me was that you were getting some orange warning messages. So actually, let me run this first so we can get it. But my guess, just looking at it, is you're passing tau range, right? And so tau range is your whole vector of tau values. Okay. So let me run this real quick just so we can see, since that was in your question, that you're getting some orange. Okay, and let's maximize this when we run it. Okay. Yeah, so I'm guessing it's exactly related to that. Okay. And your concentrations are constant. So what this is telling us is that the default method used by fsolve is this dogleg method. Okay, and so by default, this dogleg method, fsolve is looking for you to have a system of equations where you have the same number of equations as you have unknowns. Right, so by square system, it's saying that the number of unknowns is the same as the number of equations. The two other scenarios that you can have is maybe you have more equations than unknowns. Right, this is essentially what happens in a regression problem, where you try and fit two constants to some large number of data, where you minimize the root mean squared error, say, of your system. So you could either have more equations than unknowns, or you could have more unknowns than equations in principle, at which point this becomes a minimization problem. So when you have more equations than unknowns, or unknowns than equations, it uses a minimizer. And the minimizer that is built into fsolve is this Levenberg-Marquardt method. So what this orange method, or orange warning, is suggesting to me is that you have some small mistake, so that you have either more equations than unknowns, or unknowns than equations. Okay, so if we look back at your function, okay, let's maximize this. Okay, I'm going to look to see if tau range is to blame. Okay, so let's look in Solvy boy. So I like the name. So input cvals, K1, K2, and then it's again tau range. Okay, where tau range is going to be your vector of tau values. Stoichiometric coefficients, initial concentrations, you're unpacking cvals. Okay, again, this is optional. I like to unpack, so it lets me write my equations more of a natural way. Define my rates, beautiful. Multiplying tau by 60. So my rate constant's up here, right? So I'm not sure if you made a units of second inverse. So my rate expressions, right? It's so this term, this exponential term, is dimensionless. Okay, k has units of inverse seconds, so k has units of inverse seconds. So my rate has units of concentrations per second. And so basically what we want to do then is we want to multiply by tau in the same units, so that the unit of time cancels and I'm just left with units of concentration. Okay, and so what that means then is as I jump around, my apologies, is when you create tau up here, tau 0 to 300. This is tau in minutes. Okay. So here you're converting to seconds. Okay, and then you plug that into your mole balance design equations. Okay, so that looks good. I have no issue with that, but again, the issue is you're passing your entire vector of taus. So t here is a vector of tau values. So here, this is going to be a scalar, okay, because you unpacked, so CA, CB, and CC are scalars. So this is going to be a scalar. This is going to be a scalar. So you're going to have a constant times, so constant a scalar times a vector. A, B, and C are going to be vectors. And then you pack up these vectors, okay? So let's see, use linspace for tau. You use linspace, okay? So tau is a vector of length 100. So A, B, and C are both going to be vectors of 100. They'll be row vectors since you use linspace. And you pack them together, this would essentially be columns, so horizontal catenation. So this is going to result in a vector of, we'll have a single row and 300 columns. All right, so basically this is a situation where you have 300 equations and just 3 unknowns, right? Because when you unpack C-vals, it's just 3. Okay, so the problem you're solving is a system of 300 equations with 3 unknowns. So it's a minimization problem. And so basically it's going to be like a fitting, performing, say, linear regression, where you're, say, fitting 2 parameters to minimize the root mean squared error between your model and, say, 100 or 300 in this case, pieces of reference data. So the only mistake then in terms of getting this to work is you don't want to pass your anonymous function tau range, but just the ith tau value, right? You're going to loop over tau values. In each iteration, you want to solve for that specific tau. Okay, so my guess is just by changing this to tau range, that it'll work. Okay, so if I rerun it, orange goes away. Okay, our plots, we'll have to look at figure 2 is. Okay, we'll have to look at figure 3. Presumably it's selectivity, like he said. But yeah, these compositions don't exactly look right. So that gets that to work. Now we can focus on where do we go wrong. So we have K naught. So again, that all looked fine. K1 and K2 looked fine. Creating tau looked fine. CA, CB, and CC looked fine. Your plots look fine, at least your concentration plot. Here you're just calculating fractional conversion on the fly. You're converting, calculating selectivity on the fly. That's all good. All right, so let's look here then, okay, because this would be the only place for mistake. So series, so you have A goes to B in reaction 1, B goes to C in reaction 2. Initial concentration of A, B, and C. You unpack rate expressions. Yeah, this is a negative sign because my mole balance, let's see if I can go back to the reading, right? And you won't have the final version, but if I'm just looking at this, this is out minus in is that net rate of consumption. Okay, so when you say we're to bring it over to the left-hand side, so that it equals 0 like an error function, this would become negative. Bam. Okay, that looks good. Okay, now, so that was fractional conversion. Not sure why there's a blue line up there. You might have to look at it, unless I just didn't close the plot before. Selectivity, and then your concentrations look good. So this is characteristic of your series reaction, where this is B, right, my desired product, which is my intermediate product, that's going to go through a maximum. But now I look at your legend, you have all red, so we still have a couple of things to work out. Alright, so that fixed it looking real. Now if I look at figure 1, CA, CB, and CC, RGB. So why? Oh. Okay, so one thing I'm going to do, just because I'm not, had everything on there. So when you have hold on here, that should open up a figure that by default is figure 1. But I'm going to put hold on here because I don't see why your legend should have been all red. Why it should have looked odd. Okay. Is there a plot somewhere else? Let's... So I'm trying to look at is your legend. It doesn't make sense to me why they're all red. No figure windows open because I plot tau versus CA, tau versus CB, tau versus CC. That's red, green, blue, and they came up as red, green, blue. Your title, your X label and Y label, then legend ABC. And then you have this here. What is this? Okay, let me see. Is there something I'm missing? It's also up here on your conversion of A. What am I missing? Oh! Okay, here's the next one. So, zeros. When you give a single argument, by default, it's going to create a matrix. It's going to create a square matrix of this many rows and this many columns, right? So if I do zeros, right, 1, 3, then I get a row vector, 1 row, 3 columns, right, like we're accustomed to. If I just take 3, I get a 3 by 3 matrix. And so then what's not clear to me, right, let's just test this out. What's not clear to me then is if CA, CB, and CC are a matrix, and I just use a single index, what am I referring to? So let's just do say t is equal to zeros of 3 by 3. So if I were to type t1 is 5, okay, it updates. So well, 1 is not clear if it's the row or column. So when I just have a single index, it's referring to the row. Okay, so this would create what do you call it? This would be a column vector. Essentially, you're writing everything to that first column, and then tau range is a row vector. So what not sure what it's doing, all right? But apparently, if this is going to be a 100 by 100 matrix, you're just writing to the first column, where tau is a single row. So in these, you have a 100 by 100 matrix where you're writing your concentration just to the first column, and then you have a bunch of zeros. So first thing I'm going to do, and actually, so even to make things easier, so we could do 1 comma length tau, because I know linspace is creating a row vector. Okay, the easier thing you could just do is you could just do size. Okay, so remember, size is going to return a vector where the first argument is the number of rows followed by the number of columns. Okay, and so instead of just 1 comma length, since I know it's a vector, I could just as well use size, right? And let's just see if that magically fixes everything. Yeah, so look at that. Now I have this beautiful legend, right, where A, B, and C are properly colored, and that odd line that's down there is gone. Okay, conversion now looks good. Just have that single line, and then B looks good. Cool. All right, so we cracked that nut. Now, just a couple of things as you play with your code. Right, so one, if you want, this is tau. Okay, so one way to get tau is \tau. Give me a Greek letter tau. Looks like I only typed that on the last plot. All right, tau. And I think, as I mentioned, right, you could play around with things such as rather than have a separate function for each case, you could just make, say multiple and input, and then k0.2 could just be multiple times k0.1, right? And so then you could run this for the case of multiple of 0.1, all right, which is what you just had. Bam. Then if I want to look at the case where the multiple is 10, right, I can just rerun it and change my input to 10. All right, and so that's something that you might consider. So you just have the same function you just apply each time. What other little suggestions? So if I look at your error function, I think you had some constants defined down there, like your stoichiometric coefficients and initial concentrations. All right, so this stuff, right, you could always move up to your top function, and then you could just pass them to your function via your anonymous function there. You could just add them to your list of inputs. That way, if the problem slightly changed where stoichiometry was slightly different, you could tackle it. But rate constants would have to be down here because you're solving for CA and CB, and so you have to define those within your error function because you're solving for CA and CB. Right, they're going to change each iteration of tau. Okay. But those would just be some little things, just like you could think about saving your figures, and then right now you have it set up so it returns res, but res will just be the output from your last fsolve command for that last tau value. And so if you wanted to return, say, a big matrix with T, CA, CB, and CC, you could do that. Let's see, you could do res is, say, so tau range. Okay, what I'm going to want to do though is tau range is a row vector. Okay, I want to make it a column vector. I want to set this thing up like a table, like something I might think about pasting in Excel. So to go from row to column, I use this transpose operator. Okay, so tau range, CA, CB, and CC. Right, so I could set this up like a table. Okay, so if I were to run this, I'll suppress, say, the output, just so you don't get everything displayed. Bam, bam, bam. Well, I didn't store the output to anything, right? So it's just an answer. I say double click on it, so it pops up in MATLAB's version of an Excel sheet. Something doesn't look right because the initial concentration of A should be 2. Oh, it is 2. I just missed it, right? So here's time, concentration of A, B, and C, right? And so, I don't know. It's one thing you could do. You could also just return, have multiple optional output variables, and you could return all those. I don't know. The sky's the limit, all right? You can have fun, but at least we have your code working, and then you could play with it and improve upon it from that. So big changes in terms of getting your code to work was in your anonymous function here, you just want to pass the tau for that iteration. So you don't want to pass the entire vector of taus, just that single tau. The red flag that gave that away is the orange was telling you had a non-square system of equations, which meant you had either more equations than unknowns or unknowns than equations, right? And so that was caused by this. You're passing a vector of tau, so you end up creating more equations than you bargained for. And then the other thing that was causing your plots to get goofed up is when you pre-sized your vectors to collect concentration of A, B, and C, you didn't have one comma length, you just had length. And so when zeros gets a single argument, it's going to create a square matrix. And so we change that to size. Size will return the row number and column number from tau range and size it appropriately. Okay, but those were the two major changes just in terms of getting it to work right. Okay, hopefully that helps you. Hopefully you can wrap this up.